Exercise 2.5, problem 8, subdivision 2. Okay, let's read the problem. Find the sum of the first n of the series 0.4, 0.94, 0.994 up to n terms. It's something very close to the previous problem. The first step, we need to convert this into a geometric series. It is getting closer and closer to 1. Okay, so that's the hint we have to use. So whether we can use 1 and get all these numbers into a geometric progression. So 1 minus 0.4 is 0.6, 1 minus 0.94 is 0.06, 1 minus this is 0.006, so it's getting closer to 1. Okay, so the series is this. We are asked to find the sum. The formula for that is this, but anyway, none of this will be of use as of now. Okay. So the first step is we need to convert the given series into a geometric series. Then substitute, identify A, R and N, and substitute the values of A, R. I think N you will not be able to find it. We have to write everything in terms of N. That's what we did in the previous problem. Substitute the values of A, R in this equation and you will be able to get the sum. Okay, so let's do this problem together. So this is the given series 0.4, 0.94, 0.994. So this 0.4 can be written as 1 minus 0.6. 0.94 can be written as 1 minus 0.06. 0.994 can be written as 1 minus 0.006. The hint is, see, it is getting closer and closer to 1. So that is why we are subtracting it from 1. So you have n terms. So which means you will have n ones, 1, 1, 1 n terms, so we'll separate it out. So you'll get 1 plus 1 plus 1 n terms and take minus commonly out. So you will get 0.6, 0.06, 0.006. That is again n terms, right? Because you had every term had two numbers. So each of them will get repeated n times. Okay. So now you have broken it into two series. This is 1 plus 1 plus 1 to n terms is n, right? As I told you earlier, 1 plus 1 plus 1, if you have 10 terms, what is the sum? 10, right? If you have n, it is n. Now you see, if you take 6 commonly out, okay, this will become 0.1, 0.01, 0.001. What is this? This is another GP with a equal to 0.1 and the common ratio is 0.1 again. 0.1 into 0.1 is 0.01. 0.01 into 0.1 is 0.001. So this is a geometric progression with a equal to 0.1 and r equal to second term by first term, that is 0.01 by 0.1. So that is 1 by 10. You multiply it by 100, numerator and denominator. So this will become 1 and this will become 10. And what is 1 by 10? That is 0.1. Right? So this is the common ratio. Now you substitute the value of a and r in this equation. So this will become, so the sum will be, you will have first n terms at the end minus 6 into the sum of this series. So what is the sum of this series? That is a into, a is 0.1 into, the r value is less than 1, right? So you have to use 1 minus r to the power of n. If it is r is greater than 1, you have to use r to the power of n minus 1. Okay. But anyway, it will all get adjusted automatically. But please remember to use the correct formula. So 0.1, r is 0.1, sorry, a is 0.1, 1 minus r is also 0.1. So it's 0.1 to the power of n divided by 1 minus r, that is 0.1. So this will become n minus, n will remain throughout. Okay. So this will be 6 into 0.1. This 1 minus 0.1 is 0.9. And this will carry forward as it is. It will remain the same till the end. Okay, you see, we won't change that. Only thing, all these small numbers outside we are trying to simplify. So, and n also will remain the same. Okay, so I won't be talking about it. N remains the same. Right. So now you see 6 into 0.1 by 0.9. 0.1 will go here 9 times, or you multiply it by 10. So this will become 1 by 9. 6 into 1 is 6 and this is 9. And this 3 will go 2 times, 3 will go 3 times. So it will become 2 by 3. So the expression will be n which remains constant throughout from here, and this expression remains constant, and all other numbers, all these things gets reduced to 2 by 3. So the sum of the n terms is n minus 2 into 1 minus 0.1 to the power of n divided by 3. If you put n equal to 10, you will get this S10. If you put n equal to 20, you will get S20. So this is a generic term. See, this is a formula for Sn for any geometric series, but this is a generic term for the sum for this series. It will not be applicable for any other series. Only for this series, this formula is applicable. This generic term is applicable. So whatever value of n you put, you will get that sum. Okay. So I hope you understood the problem, but what I suggest is pause the video here and try to work this out on your own. Okay. Thanks for watching this video.